Hello and welcome to another edition of Momentum. I'm your host, John Bricotto. Thanks for being with us. Our first guest is Caroline Bearden, a senior industrial and systems engineering student from Hoover, Alabama. Caroline, welcome and thanks for being here.
Thank you.
So I understand you took kind of a long route to get to engineering. Why don't we start by you telling us about that?
Okay, well, freshman year, I'm going to be honest, I had no idea what I wanted to do, obviously, since I'll be here a fifth year. But I started off undeclared, and after a while, I have a bunch of allergies, so I thought maybe nutrition would be the path for me to go because that interested me for a while. But after a semester, it didn't really work out, wasn't enjoying it. So I went undeclared again, and I kind of bounced around ideas between majors, and I ended up in biology because I've always loved biology and medicine. That's always fascinated me. So pre-med biology was my longest major, and after working in the hospital first semester, I decided that was not for me. So my mom was like, after I changed my major, she was like, well, why don't you change it to meteorology? You know, you've always been fascinated in the weather. It's like, okay, I'll try that. I have friends in meteorology. Maybe the classes will be fascinating. So I did that, and ironically, I had a class in front of the camera, and I decided, oh, this is not for me either. So it's kind of weird that I'm doing this now, but I guess it prepared me. And I think it was my second semester of junior year, which is really late in the game to change my major. But I really couldn't see myself doing meteorology. And I just wanted to do something I enjoyed doing because I would have to do it for the rest of my life. And my mom had been telling me since sixth grade to do engineering, and I had never believed her. I was like, I'm not smart enough to do that. I don't want to do that. It's going to be hard. But I went to go talk to a few professors at UAB. I have a family friend that's the assistant dean of the engineering school there. And I talked to her about it. She put me in contact with a few of the professors there. I talked to them, and I was starting to kind of get a feel for what engineering would be like and in the workplace, not just in school. And I was like, I think I like this. So when I came back, I walked into Dr. Strotterman's office as a second semester junior, and I was like, hey, I want to change my major to engineering. And she didn't look at me like I was crazy. She was like, okay. And everyone in the industrial engineering department has been really helpful so far. They have really put me on track, and I'm only going to graduate a year later, which that's fine, one more football season, but I love it now. Finally found something I want to do.
That's great. Why industrial out of all the options? Why that one in particular?
I think it was, well, I was between mechanical, civil, and industrial when I first decided to change. And I think what drew me to industrial was the money and the business and the process side of things. It wasn't just technical. I like to see how things work and how to make things work. Mm.
And I understand that you do research in the department as well.
Yes.
Why don't you tell us about that?
So I recently got a research position through Dr. Strotterman. She sent out an email to the whole department and was like, hey, if you're interested in athletics and new wearable technology, then you should probably look into this undergraduate research. So I applied, not thinking I would get it, and then I get an email from her a couple days after, and I had gotten the position. And right now I'm working with wearable technology with Olympic sports, so like volleyball, tennis, track and field. And right now my main job is to compile the data in a way that coaches who don't have a lot of time to look at huge packages of data, just compile it into a way that they can understand and get the full picture in one document.
Okay, all right. And what about other organizations in engineering? What are your sort of outside the class activities like? Well,
I just got the secretary position for the Industrial Systems Engineering Club, and that's been great. We actually have a fundraiser coming up at McAllister's, and I've met so many friends through it. We have guest speakers come from other companies to just talk to the students and get a feel for what working for that company would be like and what real world engineering is. I'm also in a sorority. I'm in Delta Gamma. Okay. I've made a lot of friends through it. It was one of my favorite things about Mississippi State.
Okay. And what would you say, just real quickly in closing, what's different about engineering versus some of the other majors that you've been in? What stands out to you as like one of the major differences?
this engineering has really challenged me more than any other major. It's made me think in a different way. And I get to do what I love. I love math and physics, so this is the perfect department for me, and I've loved all my teachers and advisors. Like, they've been great. I think they've really made this experience a lot better.
Well, that's wonderful. Welcome to engineering. Thank you for being here to talk with us
thank
today.
you.
It's been great. We'll be right back after a break.
When you're the best, everyone wants to see what you'll do next. At Mississippi State University, our team of world-class rocket engineers is venturing beyond boundaries, building rockets like none before. We're launching a new era of space exploration. We've developed cutting-edge technology that's helping us build a rocket that can travel at 4 times the speed of sound. Fast? Yes. But more importantly, revolutionary. For you and for a space program that produces many of the conveniences we enjoy today. We're shaping your life in ways you never dreamed. What's next? Watch us and see. Imagine a helmet so protective that it transforms the safety of the game. We are at Mississippi State University, where we ring true. What drives you? What pushes you forward? Is it an appetite to be the best or a calling to make a difference? For those of us here at Mississippi State University, it's both. We're designing a future where cutting-edge hybrid technology isn't imported from overseas, but exported from our own backyard. We're working toward a day when solutions to energy independence move at 0 to 60 in 5.5 seconds and are as simple as charging a phone. A day when fuel economy and environmentally friendly are viewed as less of a compromise and look more like this. For us, turning heads in the auto industry is great, but living up to the hype is even better. That's because it's about more than simply envisioning the future. It's about getting there. And here at Mississippi State, we know just the ride to take.
Welcome back. Our second guest is Dr. Santanu Kundu, an associate professor in the Dave C. Swam School of Chemical Engineering here at Mississippi State. Santanu, thanks for being with us.
It's my pleasure to be here.
Let's start with a major grant that you recently won. Why don't you tell us about that?
Sure, it's my pleasure to be here, and I'm really excited to talk about that grant. So this is a grant from National Science Foundation. This is a $20 million grant for 5 years. And so this has been given to not the university. Mississippi State is given to the state of Mississippi. So 4 major research universities will be involved. And so with this grant, there will be a Center for Emerging Molecular Optoelectronics will be established, and there will be 20 faculties from all 4 universities. And as the effort started maybe 2 years ago as a part of the core team, we started working on this grant. So this molecular optoelectronics is a mouthful. Let's break it down. Let's put it in a simple term. So basically, all of us have seen semiconductor materials, or we know that what semiconductor materials are. They're used in a like a chip. Maybe the easiest thing to think about that, like iPhone. Everywhere we have a lot of chips there. Like one of the things that we're going to do here in this case is that instead of all those chips are silicon based. So we're going to try that instead of silicon, can you use organic? For example, polymers. So think about that. You're making some chip based on plastic, and or others. So and the applications will be a lot. Like can you make a new type of cameras that can be used for like a defense application? So you just basically capture some specific signals, or can you or making a better solar cell, or can you use this material for bioimaging? So you basically put it in a body, and you basically take a picture from the outside, and you know that what kind of problems you have. So some of the things are used for the MRI kind of stuff, but this is making it more better, much more easy to handle, less toxic. So overall, we're going to looking at this looking into new materials. I'm very excited to be part of that team, core team, and participate in this grant.
Well, congratulations. I mean, that sounds incredible, and it sounds like it's got application in a number of areas, so
Yes.
it's not limited to just one particular area. That's very exciting. I know that you're also involved in several other research ventures. Why don't you tell us about some of those?
Yes, so I'm here in Mississippi State. I'm involved in first last 6.5 years or so. I'm involved in many projects, but one of the projects I would like to mention that is really important for Mississippi, in my opinion, is that we are cotton seed oil, a project that we're doing at the cotton seed oil. So this is a project, is a part of with the agriculture school. So what do we do? What's the goal of this? That we take cotton seed oil. So that's like a not very, it's not very expensive, but the farmers don't get a lot of value out of it. Now the thing is that what we want to do, we take this materials, cotton seed oil, and make it as a plastic. Okay, so then probably we can use it and we're going to use it as a 3D printing it. A lot of people are doing it. So maybe we make some furniture, maybe we make shoe soles. So you're making a value-added product, so the farmers will get a benefit of that. And another important point will be that, like if you take these materials, these are biodegradable. These are inherently biodegradable. So once you're done, if you have suppose you bought a materials, furniture made of these plastics, once you're done, you throw it away, and it will basically going to degrade, and you'd have very little environmental footprint. So that's I'm very excited to be part of that project.
Wow. And then another part of all of this, of course, is the effect on students. And I know that you're very active in getting your students involved in this.
Yes.
Why don't you talk about how you engage your students in this research?
So the research I am doing cannot be done without the student. They are the main driving force, our people who are doing this research. So in our research, at any time, we have graduate students, undergraduate students, and postdoctoral research being involved. So for example, presently I have like four undergraduate students in my lab, and there are 6 graduate students. So and the thing is that like graduate students, they basically get trained in advanced technique, advanced science, all these things, and then they go to join industry, and basically they continue to do that research, and they're going to get like really become great scientists. For undergraduate students, this is super also beneficial, because they're learning something in the book. Now they come to the lab, they apply those things, and these are like open-ended problems. So this is not a problem they just do it in the class like there is a one solution. There could be, they have to come out like innovative, creative to get a new solution. And I think that's the way they get to get really practical training at the same time they're learning something really, really new.
Well, that's incredible, and I congratulate you both for the grant and for involving students in your research this way. Thank you so much for being here today.
Thank you very much.
So that's our show for today. Remember that you can follow us on Facebook, Twitter, and Instagram at MSU Engineering. Thanks for watching.